Now we have a two-dimensional problem. This one, these are 3 cars, and they're on a raft. That's what the square is. And so we want to know where the center of mass, where is the natural place for this system to rotate. And you'll see I wrote them out in both the x and the y, but they're exact duplicates of each other. The equation itself doesn't change. It's just what axes I'm looking at. Am I looking at the x or am I looking at the y? And the other thing I want to emphasize real quick is, because I keep drawing these out as m1 plus m2, this can be continued on. I can have y84, y8642, which is an odd number just to come up to the top of my head, but that's okay. Okay, so the first thing I did on this problem is I created my own axes. This point here will be x equals 0 and y equals 0. So I'm going to start all of my measurements off from there. Now, if you had chosen to make your axes here, that would have been totally fine. You'll get the exact same answer. You're just going to get it coming from this axis. So if you compare answers to your friends and see that you have what appears to be a different answer, what you want to do is compare where it lives on both of your drawings, because I bet they match. All right, so that aside, let's see what we can do here. We can go for our x then. What do we have? We have mass 1, and they're all the same. So 1,200 kilograms times, let's see, 0 plus 1,200 kilograms times, let's see, this distance apart is 18 meters. Plus, now this one, even though it's up here, we're only looking at the distance away from the axes. So plus, again, this is 18, so 1,200 kilograms times 18. And the reason why I included this 0, I don't expect you to show it in your work, but it helps me remember that there are 3 masses that I'm comparing that have a total mass of 3,600. Otherwise, the most common mistake to make here is you see just the 2 masses because you mentally drop off the one that's times the 0, and then you only add those 2 masses in together. And so that creates some problems. So what do we have? We have equals, let's see, 18 times 2,400 divided by 3,600. And that gives me 12. I was going to show you some math tricks there. I guess we could do it if we wanted to. So for putting things into my calculator, the first thing I'd realize is these 2 zeros would cancel out. This is like 10 to the 2 and 10 to the 2. So then I'd have just 18 times 24 divided by 36. And then I would look at this and I'd be like, so I feel like I can simplify this sum, right? This is 9 times 2, and this is 9 times 4. So there's a lot you can do to simplify that, but just removing those zeros will add in a little bit of leeway for not making some of those math boo-boos. So that's happening at 12. So let's see, here's 18. So 12 is going to be, let's see, 9 would be midway. So 12 is going to be about, I don't know, about right here. And in the y, ooh, look, I have 2 on the y-axis. So I'll write those out that I have 1,200 times 0 plus 1,200 times 0 plus 1,200 times 18. Because the 0, again, they're on the axes. They're on the place that I've decided I'm going to define my axes from. And then the important thing is I make sure I include all of my masses, 3,600. So that cancels out, and so I get that my y location is at 6 meters. So let's see, about 1/3. So my center of mass is going to be somewhere around here-ish. So if you had started from here, you would get the exact same answer, but it would be like in the negative direction from here. So it would appear when you did these values, that's what I'm warning you on, when you do these values, they would be different. But that's only because you're measuring from a different location. So what does that say? That says that if this thing started to rotate, it is going to be, let's see, about 1/3 or 2/3 of the way from that mass, close to these 2 masses, and that's where it'll rotate. Now the temptation might be, you look at this and you draw a triangle and you go, so if I pick here, then it looks like it's going to be like smack dab in between all three, which seems like it would be a more natural place. That would be true if I had another mass, same size mass, distributed in that corner, because what that spot would be smack dab in the middle of all four masses. But here we don't have a mass over here. So that's why we have this shift of the center of mass closer to these two masses that are closer to each other. You see that? Chew on that.